Good morning, good evening, or good afternoon, and welcome to this instance of the Antrea committee meeting, which is, I think this is the first of year 2025, because we skipped the last one as it fell on December 31st. Anyway, so for today we have the only topic that we have in the agenda is a discussion of several issues pertaining layer 7 network policies, and these will be led by Hong Liang. So Hong Liang, please go ahead.
Okay, so I'll share my screen. 2 minutes. So 1. Okay. Could you see my screen? Hello?
Yes, we can see it.
Okay, thank you. Okay. I only prepared the proposal for fixing the issue 68554. This issue was made by Antony. Maybe you can open the issue with some background. Of course, I'll introduce the background about it. The issue is about layer 7 and layer 7 network policy. For in our design, for the port-to-port connection, we can see the path of the request packets. It is originated from the port 4 through OVS pipelines, then redirected to Suricata, where ensure layer 7 type 0, and after processed by Suricata, it is sent through ensure layer 7 type 1, and then re-enters OS pipeline. Then it will be forwarded to its original destination, the port file. This is the request package. For the reply package, the process was similar, was almost the same. You can see the reply packet will be also sent to Suricata and sent back through the type 1, then send back to the port 4. Okay. Next is about the service connection. This is the expected. The expected status for the request package. It will be united in the OS pipeline. We can. This is the test service IP and 10.96.1.1. It will be united to the port IP 10.10.0 file. And we can see in Suricata, the connection is from 10.10.0.4 to 10.10.0.5. For the reply package, it should be like this. The reply package should first redirect it to Suricata first, and after the packet is sent out via type 1, it should be united in the OS pipeline to recover its original service IP and 10.96.1.1, and finally it will be sent back to port 4. But we got some trouble. We got some trouble in the actual pipeline. The request packet, everything is okay everything is okay for request packet. You can see, and this almost, but we got some trouble for the reply packet. For the reply packet, for the reply packet, when it when it, when it is sent out through the pod file, it will be undenited. It will be undenited first and sent to Suricata. You can see the the destination IP address is not the pod IP. It's the service IP. This is unexpected because Suricata don't know this connection. So Suricata will drop the packet because it's unknown. The known connection is 10.10.0.5 to 10.10.0.5. But this connection is unknown, So Suricata will drop it anyway. Okay. Any question about it? No? Okay, I will continue. For the first proposal, what we need to do is guarantee that the reply packet from the pod file will not be denied in the first phase. In the first phase, this phase is guaranteed packet to be redirected to Suricata without anti-net and without anti-net. To to implement this, we need to do some change to the pipeline. The change is not a minimal change. It's a little it's a little bit. So I believe everyone was very familiar with the denied flows. I didn't show the flows here. So for the service connection, it will be pass the service LB table, then will be denied, and in Antrea policy egress rule, we need to introduce we need to replace the original IP filter to using TCP because we need to add an extra learn flow to match the reply packets. The reason why we need to replace IP with TCP is because we need to use the register about TCP. If you use IP here, these two register cannot be used in the learn flow. The learn flow.
I got a question. Why we have to use learn flow instead of matching some label or state in the CT state instead?
We use learn flow we don't want to introduce another CT action because that will downgrade the performance. The proposal one is much complicated because we introduced mass flows to avoid additional CT actions.
Not sure if there will be a new CT action. I was just thinking if we could mark the flow. Maybe we already did that. I mean, having some mark or flag in CT state of a session, indicating that it has been netted in any way. And then for the reply packets, maybe we could just check whether the reply packet belongs to any session that has been netted and has been processed by Suricata, and just forward such kind of packets to the type 0 device.
I got what you mean. Maybe we can just jump to proposal 2. The proposal 2 is the idea as what you said.
Okay, I just want to mention previously we use run flow in other scenarios. It's because city state is not valid in that scenario. For example, the server side return, DSR feature, direct server return, because the connection is not a complete connection on the ingress node, and we cannot use city state for persisting any state of a connection. So we have to use long flows. And I think city state is kind of more convenient and efficient than long flows in OS practice. We should use that as much as possible instead of using long flow. Yeah, maybe you can introduce the other one.
Okay, this is much complicated and maybe take more time to introduce. The second one is much simple. Yes, the second one we only need a minor change. We need another for the flow in Antrea policy egress rule. We only need to introduce another reg mark to identify the packets should be suricata, should be redirected to suricata. And for the first request, okay, I need to mention that then the flows in red are new flows. For the first request packet here. Sorry. Yes, here is before. It is here. It's after denied, and after denied it should be here. Sorry. Okay. I add several flows to the contract table, contract join. The first one is to we can see it introduce another city operation. Its destination is itself, but the difference is it doesn't have an AT keyword. With this city, we can restore the city mark, city labels of a connection with and the AT state would be restored. So for the first request packet, it will be masked by this flow, and then its state is about it will be masked by the city state not replied and tracked and with the city mark. This city mark is for layer 7 network policy. Okay, this and this track mark we have mentioned before. It is used to identify the packets which should be redirected to Suricata. And then I didn't demonstrate all the flows. And finally, it will be forwarded to output. In output table, we match the we match the new reg mark to forward the packets to Suricata. Okay, now
Can you explain the purpose of the second flow that sets field to 8?
You mean this one?
Yeah. I didn't see it being used in other place.
I want to avoid the packet I want to avoid packets forwarded circularly in the city contract zone because we match the rep 0 with the with this rack, and we set it to another value, so the packet won't be okay. I think you got it.
I see. Yeah, I saw that. You mean this flow itself will be the only one checking this rack, right? To just avoid executing the same flow another time. And the purpose of this flow is to restoring city states.
Yeah, just restoring city state without NAT state. NAT.
Didn't we have other existing flows to restore city states? No.
I'm afraid that we don't have such one. And the only flow is this one. All packets will be pass city with a NAT keyword.
Okay.
No, the packet is here, and it was returned from Srikata. So in the classifier table, we need to strap the relay metadata and send it to contract drone. Then we still the packet will be still masked by this flow. Next is state. We can use the keywords since it's from the type 1. All packets from type 1 will be tagged with 6, with the value 6 for the first 4 for the first 4 bits in rep 0. So it can be masked by the third flow in contract 0. And the state is not replied and tracked. So finally, it will be sent to the serial forwarding to match to modify layer 2, layer 3 metadata, and it will be finally sent to a table output to decided which port it should be forwarded to. We have a high priority for the packets from type 0 Antrea 7 type 0 with this keyword, and the register will be cited in like layer 7 forwarding or layer 2 calculate. So the packet will be sent to its original destination of file with the IP address 10.10.0.file. Okay, any question about it? Okay. The next, we need to handle the reply packets. So the reply packets, we can distinguish the reply packet from the ordinary traffic, like from a pod to another pod. So out traffic, I mean out traffic from the pod managed by Antrea should be passed to the display to fetch the city state. For reply packet, we can say that its state is about its reply packet is tracked and it has a city mark. So because we want to skip undenied in the first phase, in the first phrase of reply package. We want to send it to Suricata directly. So we cite the reg mark introduced. We introduced and send it to output. With the reg mark, it will be masked by the second flow in output table and forwarded to Suricata. After came out of Suricata, it will okay, the next one, this one. After came out of Suricata, it will be masked by still mask this flow, and then this one. Here we need to perform an undenied to restore its original destination IP. So we can see it will be masked by the flow with the keyword matching reg zeros. The first bit is 6, and its city state should be reply and tracked. Its action is to with the city's connection city operation, sending to the layer 7 table to calculate layer 2 and layer 3 metadata. The most important is the NAT keyword. It will help the packets restore its original destination IP from 10.10.0.4 to 10.96.1.1. Okay, after undenied, it will be masked by this flow to send back to pod 4. For the subsequent request packets, they are almost the same. We have 4 flows to mask different cases for reply for request, and the packet sent out by Suricata. Before sending it to Suricata, we also need to do denied to restore the denied IP. So the subsequent request packet should be masked by this flow with the city state and city mark. After denied, it will be masked by this flow and sent to Suricata. For the package, if after it was returned from the Suricata, almost it will still masked by these flows and sent to the destination pod. Okay, the proposal one is much simple. The first proposal, we to be simple, I want to say that in the first proposal, we use learn flow to achieve the same goal, and let the reply package to be forwarded to Suricata first, and then after it was returned from Suricata, we perform undenied to the reply package. That's all we want to do. So for the as we can see, the advantage of the first proposal, we don't need to introduce a new city accent. So the performance should be better. And the disadvantage is that we need to do much change to the pipeline, and it will require more code change. For the second proposal, as I said, we only the main change is here. We need to introduce four new flows. Sorry, the file flows. But it has the side effect. All the traffic will be impacted by this flow with another city operation. I think it will downgrade the performance for all traffic. The first one, well, the first proposal will not impact other traffic.
Is the performance difference based on theory, or you measure the two implementation and find the and can observe the performance difference?
Sorry, I didn't make any performance test yet, but for the second proposal, we introduce these flows, and it will be masked by all packets, all packets from all passing the pipeline. It's another city action. I remember that we said the city action is much heavier than ordinary matching, like a register or something else,
yeah.
maybe.
That's true for city action, but I'm not very sure whether the learned flow will have larger or lighter impact on the performance. But I remember it kind of invalidates some caches. So that's why I asked you the question. But anyway, I think even in the second approach, we could use the feature gate, or whether there is any level 7 error policy has been enabled to avoid always making all packets going through the unnecessary flow, right? If there is
Yes.
no level 7 error policy, we could keep the flows as it was, right? And only do it. The reason why we need to have this action, extra city action, is because we cannot differentiate without knowing the state, right? We cannot differentiate reply packets from pods that need to be processed by Suricata or not. So we need to restore the action. We need to restore the city state without performing net unconditionally, right?
Yes, your understanding is correct. We must introduce another city to get the status, and then we can distinguish the traffic affected by Suricata and to do the specific operation. Otherwise, we cannot tell them from the ordinary traffic.
I see.
Okay. That's the fix about the proposal. If you guys are interested in the first proposal, you can see the slide later. But the first proposal is much complicated, and I want to continue to to introduce it. Okay. Any question about this one? All the second protocol is much simple. All the flows are here. All the new flows are here to resolve the issue.
My personal opinion is using simpler solution and use conditional code to prevent its impact on scenarios that do not need this feature.
Okay, I know. Personally, I prefer the second one because we don't need to mass code change for this one. For the first proposal, I also need to make some code change to the existing network policy flows because I need to change the condition from this one. Sorry. I need. I have evaluated the effort about change the keyword. This I need to change the keyword from. If I need to change the keyword from IP to TCP, we need to do mass code change. No. Of course, the learn flow will also take much effort to implement this. Well, for other reasons, I think these flows can be isolated by gate. Of course, we need to document about the performance downgrade when users want to enable Learn 7 network policy. Because
not only feature gate, but also whether there are Layer 7 network policies enabled on this node. Even in the future, we graduate this feature to beta and enable it by default. I suppose that a cluster that never use the 7 network policy should not have this performance downgrade. And if the performance downgrade is minor, maybe we don't really need to document it either, in case it introduces some unnecessary concerns to users.
Oh, I got what you mean. You mean if we graduated the feature and then this flow should be isolated by the option in the future?
I mean, like, I assume that we only start Suricata when there is an actual need. Is that case? Is that the case? I'm not quite sure, but I assume that for resource, to reduce resource and improve performance, we should, because this is not a really very common feature and widely used, right? So I assume it's worth to do not run the process and install the unnecessary flows until user starts using Layer 7 network policy.
Okay.
It's just like a lazy mode.
I know what you mean. You mean just like the Suricata process, we didn't study it until user create a Layer 7 network policy.
Right. Maybe one user would use it, but it's not worth to make the performance worse for all users.
Okay. Any comments about the proposals?
No comment from me. Does anyone have any additional comment on this proposal? All right, I presume we can move to the next step, to the next one.
Okay, I stop the screen.
So I think Hongliang prepared one issue, which with two proposals. Another two, I think it's already in progress, so he skipped.
Indeed. Okay, so that was the only one that needed a conversation. For the other ones, we don't need to discuss them, right?
Yeah, that's right.
Okay, that's perfect then. So that might also be all for today, unless somebody has anything else to discuss. It doesn't seem it seems that there are no other topics for today. So I would like to thank Hong Liang for his presentation and Chan for contributing in discussing the resolution. And thanks everyone for attending this meeting, and we'll meet again in 2 weeks' time. Have a great evening or a good afternoon.
Thank you.
You, bye.
Bye-bye. Bye.